one. The normal probability distribution basically looks like this. It has a curve that is completely defined by the mean and the variance under investigation. So the properties, as you can see from the diagram, is that it is bell-shaped, number one. It is asymmetric at the mean, meaning the left mirrors the right side. It's half. So this line of symmetry here, the mean, the median, the mode coincide. It means they're the same, they're equal. So this curve approaches a horizontal axis. They don't touch the base, in short. It goes infinite. They don't touch the base. So the area under this graph basically is equal to 1. So this is the property you need to understand on these normal distribution tables. So now the statistical tables, you need to understand how to read them before we go into the calculations there. So what did I say are the 3 properties of normal distribution? Actually, 4 properties. Number 1, what did I say? Can you remember before we go any further?
The area under the curve is equal to 1.
Area under curve is equal to 1. What's the other property that I just mentioned?
Well, it's divided in 2, and half part of the curve, say the left part, is the mirror of the right, meaning they're divided into equal parts.
Good. It's asymmetric. What else did I say? It is bell-shaped. The mean, the mode, and the median are equal. What else did I say? The last property? What else did I say about the properties? Okay, so now let's go to understanding the tables and how to read them. So these tables are very important. This is called the statistical table. Now these tables are read in a special way. So this is what we call statistical table. So if you've got a reading code 1.23, you read the first 2 numbers and the last number. These are the first 2 numbers and the last number. So this is 1.2 and 0.03, where they meet. 1.2 and 0.03. So let's read. Give me the reading for 1.23. 1.2 and 0.03. Where do they meet? 0.8907. 0.8907. So this means that the area from here to here is 50%. From here to here, 1.23. This whole area here is 89% or 89.7%. So these areas under the graph represent the probability. Okay. So Let's try another one, 1.96. Who can help me read the reading for 1.96?
Uh, 1.96 is going to be 0.975.
So 1.96 here, got 1.9, and here 0. What? 0.06, where they meet. 1.9 and 0.06 here, where are they meeting? 1.95, 975.
975.
Correct. So we are reading from Z to P. So if I told you that this is my probability, 0.9750 give me the Z, you simply add 1.9 and 0.06. 1.9 and 0.06. So this will give me a Z of 1.96. If I told you to say the probability of 0.8907, what is a Z? You add 1.2 and 0.03. Together, you're going to get 1.23. Issue. I would ask you, give me the Z for this second one here. So what is the reading for 0.6879? This is the probability. Give me the Z for this. Who wants to try? Esther?
The Z for
0.6879.
so it's 0.49.
Yes, 0.49. So what she did is simply adding 0.4 and 0.09. You get 0.49, correct. So this is reading from probability to Z.
Sorry, are you able to demonstrate again on the curve? Just maybe two more. The way we found for the first one, the 1.23.
So 0.96, how do we read 1.96? So we read 1.9 here on the, then here 0.06 where they are meeting here. So we say the reading here is 0.9750. So this was found when we went into the table here, 1.9 and 0.06. So this means that 97% is illustrated coming from here. So this is 50 and this is 1.96. So this means that 0.9750 or 97.5%, which makes sense. So from here to here is about 97.5%. All right, is that clear? So sometimes you'll be asked to read from inside the table to say, okay, the probability from here to here is 0.9803 or 98%. So give us the Z reading for this probability. So this is 98.03. So what is our Z here? So you'll be asked to, you need to check inside the table which one is corresponding to 98.03. Let's check from inside the table. Give me the corresponding figure 98.03, 0.98, 0.9803. Okay.
So that would be 2.06.
Good. You check inside here. It is coinciding. So sometimes if you don't have the exact one, you get the closest. So this is, we have an exact one. So 2.06, correct. So the Z is 2.06. All right. Suppose you're asked to find the Z for 0. 0.9130. 0.9130. What is the reading for this? If you don't find the exact one, you get the closest one. 0.9130. What is the reading?
We have something close or at 1.36.
Okay. 9130. The closest is 9131. So this is corresponding to 1.36, correct? Are you following? 1.36. Right together? So that is our Z. Help me find, how about 9800? What is your Z for 9800?
Zero point 9821.
0. So for this one, you need to be very exact. There are two numbers that are close. All right. Which one is it? Which is close to 0.9800? There are two numbers which are close. So I'm teaching this for those of you who are joining us the first time, like a baby. So please don't go any ahead of me. Let's move one step at a time. So these numbers are in chronological order. So when you go here, you just follow through. There are these two numbers that are close to 98%. So this one is above by 3 points, and this one is below by 2 points. So the most exact is this one, which is below, so 2.0, 2.05. Right, so the inward reading and the outward reading. Right, so with that being said, now I need to take you to grade 1. Let's understand the symbols. Greater looks like what? Greater looks like this. Means shade to the right. Less looks like what? This, shade to the left. Okay. So greater, shade right, less, shade left. All together. So if we're going to illustrate, So you tell me which one. So if we're going to say the Z greater than 2, Z less than negative 1.2, Z greater than negative 1, Z less than 2.5. So which one coincides with which? A, B, C, D. So we have 1, 2, 3, 4. So A, Z greater than 2. So greater than 2 is here. We're shading to the right. Less than 1.2. We got the 1.2 is on the left side, so we're shading here. Then greater than, less than 2.5. 2.5 is here. We're shading on the left side. Greater than negative 1. Negative 1 is here. Shading on the right side. Okay, let's mask them. Okay. Are we seeing the shading?
Yes.
So now one thing I need you to understand is that shadings here that are small and shadings that are big. So shading that are small and shading that are big. So this is a small shading. Whenever the shading is small, we subtract from 1. This is a big shading. We read directly from the tables. Small shading, we subtract from 1. Big shadings, we read direct from the table. So let's go back to our reading lesson. Can somebody give me the reading for 2.0? What is the reading for 2.0? And what's the reading for 1.0? Quickly.
Sorry, Mr. Are you able to just go through again on the subtracting and adding?
No, I'll get to the subtracting and adding after this, because that's what I want to explain now. So 2.0, what is the reading for 2.0? So we want that 2,
0.9772.
0.9772. About 1.0.
1.0. 0.8413.
Good, 0.8413. Let's go back to our application. We're saying this is greater than 2. So we go to 2 and we shade to the right because the sign says greater. What determines where to shade is the sign. So we know that the sign from here up to the end is 1. But from here up to here, if it's 90%, the remainder here is what? 1 minus 0.9. We subtract from 1 because it's a small shading. From here to here, if it's 0.88, we read from the table because all the readings from the tables are more than 50% there. So we don't need to subtract. 80%, that's 0.8. Okay, that's what I meant. So This is how we apply the tables now. Suppose we've been asked to read to shade greater than 1.23. Let's illustrate. We use ISA to illustrate. ISA stands for what? Illustrate, shade, standardize, apply the principle. So let's go to 1.23. 1.23 is a positive number, so it's on the right side of 0. 1.23. Step 1, illustrate. Step 2, shade. What sign is there? Greater. So which side are we going to shade? To the right side. Are we together? On the right side. Is this a small shading or a big shading? It's a small shading, right? Whenever the shading doesn't cross the middle line, it's a small. So obviously the answer we're going to get will subtract from 1. So let's go to 1.23. 1.23. Can you give me the reading for 1.23?
Sorry, Miss, before you, I'm a bit, if you go back a bit to the shading, you said that we're trying to establish Z is greater than 1.23. Yes, so that is our 1.23. Ah, okay, all right. We are heading to the right after 1.23. I thought we should shade the, okay.
So what determines greater is shade the right. If there was less, we would have shaded to the left side. The second thing you should ask is this shading proportion, is it big or is small? All right. So I was trying to illustrate to you to explain to me what is happening in the shadings here. So I want you to tell me 2 things that are happening in these shadings. Whether we're shading to the right, whether we're shading to the left, whether the shading is big, whether the shading is small. Okay. So once you get this understanding, it will be easy for me to explain what follows. So shading number A, B, and C. Can you tell me what you can see? A, B, C, and D. What is happening in A?
We're heading to the right.
Number 1, we're shading to the right.
Mhm.
Number 2.
And because the shading is small, so the reading will subtract from 1.
Good. The shading is small, so the reading will subtract from 1. Good. So 1 minus the probability. Correct. How about shading B? What can you see from shading B?
Yes, so equally, the shading in B, it's small to the left.
Number 1. Point number 2. It's to the left.
So yes, in
Sign
the same manner,
less than. In the same manner,
the reading,
the read.
yes, the reading again will subtract from 1.
Good. Great. Okay, part C. What's happening?
But see, the shading is big, despite it's to the left, but it's big, so the reading will just write as it is.
Good. The shading is big, so we read directly, and also it's what? To the left, meaning less than. So less than doesn't determine whether it's big or small, just in the direction. Right shading. All right.
Mhm.
Okay. Next, lastly,
Even D as well, we can see the shading is to the, okay, it's big, and
it's big. Number 1.
yes,
Mhm.
I think it's more concentrated to the right. However, the reading again will not subtract, we'll just pick the reading as our answer.
Good. Okay, so once you get these instructions, this is what we call apply. It's application. So we now go back to our issue here.
Sorry, before you go back, just as she was explaining, I'm trying to grasp the subtracting and just picking the. Are you able to say something again?
So whenever the reading is big, so it means that you can see here, all these figures here are more than 50%. They are big. So there's no need for subtraction from one. You get it as it is because the assumption that the area which is being shaded is a big one. It means that it coincides with the table which has big readings. So there's no need for subtracting. But when you know that this shading is small and all the readings I'm using the cumulative table, so I need to subtract to get the actual reading. That's what I will mean. All right. So some of these things we get them as I explain as we move on. So greater than 1.23. So we first to find 1.23, greater is to the right. Okay, then we shade. This shading is small. So let's read 1.23. When we go to 1.23, it is giving us 0.8907. 8907. So this means from here to here 0.8907. So automatically it means that to get this shaded region, we subtract 1 minus 0.8907 because this is 89.7%. This cannot be 89.7, so we need to subtract to get the difference. You now get it, eh? So give me the difference, eh?
Yeah. So, Mr. Collins, what was the answer of the question?
Here's a question. Find the probability that Z is. So what are you getting? So it gets 0.1093. Okay, that's question number 1. Question number 2, let's find the probability is less than 2.25. Let's illustrate. Who wants to help us illustrate? Step 1, illustrate. 0 is here. 2.25 is here. What are we going to shade? Put our divider. Where are we shading? To the left.
So following the symbol, yes. To the left.
The left. Then let's look for 2.25. When we go here, 2.5. Remember the format of reading? 2 and 0.25. So 98, 78. So are we subtracting or reading direct?
This one will just read directly.
Because
As we can see, the shading is big.
exactly. The shading is big. So you can have a negative Z as well if you're on the other quadrant. So the side of the quadrant, okay, suppose we have negative what? -2. Then you are told that find the Z less than -2. So you go to -2 here, we're going to shade here. Why are we shading the left side? Because it's less than. Then let's look at -2. But even before we look at -2, the answer we're going to find, we're going to subtract because this is a small reading. So the negative just shows you on the negative side, but we're just using the positive tables. Of course, there are also negative tables, but I want you to concentrate on just one table for it to be easy for you. So -2.0, this means 0.9772. It simply means that from here to here is 0.9772. 97%. It can't be from here to here 97%. It's not true. 97% should be here. Since we said it's asymmetrical, whether I'm starting from here or I'm starting from here, the areas are the same. That's why we need to know the properties. So I'm going to subtract 1 minus 0.9772. So the difference is what we call the probability that will remain. So 1 minus 0.9772. Okay, so we're going to get 0.0228. That is what we are doing here. All right. So we can also have the probability of Z greater than -1. Z greater than -1. So illustrating this, our -1 is here. We put a divider. Where are we going to shade? We're going to shade on the right side. Are we shading on the right side? Because the sign says greater. So when we shade on the right side here, what are we seeing? A big shading. This big shading simply means that whatever we read, don't subtract from 1. So we go to 1.00. So 1.0 is 0.8413. So 0.8413. So we're not subtracting from 1 because this shaded area is indeed big. Any questions at this point? Any questions at this point? Are we moving together? All right. So sometimes you'll be given intervals to deal with. Find the probability between Z is between 1 and 2. So 1 and 2, they're both on one side, they're both positives. So 0 is here, 1 is here, 2 is there. 1, 2. So we're looking at the interval between these two. So there's nothing to do with 1 here, just get the big reading. What is the reading for 2? What is the reading for 1? So when you check in our table, the reading for 2, by now we would have memorized them, 0.9772. The reading for 1 is 0.8413. You can check them to just confirm them. The reading for 2 is 0.9772. The reading for 1 is 0.8413. So whenever they're on one side, just subtract the bigger minus a smaller percentage. 0.9772 minus 0.8413. Subtract the two intervals. Okay, so that is what we do when we're dealing with what? Two intervals. So this will give us 0.9772 minus 0.8413. So we're going to get 0.1359. So this is the interval. Suppose they're on both negatives on one side. Probability Z is between 0.2 and -1. As long as they're on one side of the quadrant, we still subtract them. So here we have -2 here and -1 here. Since they are symmetric, that's the principle of asymmetric, they are on one side here. When we read 2, we're still going to find out 0.772, 0.8413. When we subtract these two, we're going to get the difference that we just found, which is 0.1359. It becomes a difference when we're looking at an interval between two quadrants that are on different sides. So maybe you have -1 and you have +2. So in this case, I'll teach you a new principle to apply. Our 0 is here, we have -1 there, and here we have +2 there. So what do? This is 0.8413. And this is 0.9772. So what you do, just add them and subtract the 1. That is what we do if they're on opposite sides. If they're on opposite sides, what do? We subtract them. So when you add 0.8, 0.8413. So we're going to get -1, so we're going to get 0.8185. So this is when they're on opposite sides. Let's do it quick. Can you remember? Suppose we have an interval between 1.2 and 2.5. What do we do? What case is this? It is the same side case, right? Where's 1.2? On the right of 0. Where's 2.5? On the right of 0. What do we do? Read them. Then subtract the bigger one from the smaller one. So go to the table 2.5. 0.5 is here. So 99, 38. 99, 38. So this is 99, 38. About 1.2. With 1.2 here, 88, 49. 88, 49. What we do, we subtract the bigger one from the smaller one. All right, I don't want to get the actual figure there. I just want you to get the concept. Suppose we had negative 1.9 and Z is between 2.05. What case is this? Then opposite sides. One is on the negative side, negative 1.9. One is on the right side, 2.05. What we do with them? Then add them and subtract a what? A 1. What principle is that? Case 3. All right. So before I go to standardizations, let's see what our modules say. We'll look at some examples before we go to standardization. All right. Let's look at what our modules say. So example 4.13, 4.12. Z is less than 1.3. Z is less than 1.3. So we illustrate here with 1.3 on the right side. Less than is on the left, so we're going to shade this side. Now, what does this shading tell you? It's a big shading. So when you read the table, we read directly. When you go into 1.34, it is 9099. Let's confirm with our table. Is it the same? Are we getting the same answer? 9099. So let's go here. So the reading for 1.34. So 1.3 under 4. Here, 9099. So you see that it's coinciding with what we have here. Are we following? Cecilia? Are you there? Goya, are we following? Then Z is less
Yes, Mr. Collins, I'm here.
Z is less than 2.75. I'm really interested in those that were almost giving up so that I could show you that this is a possibility. This is the toughest topic, but I want to take my time so that you understand the concepts. Okay, the other week we'll start our revisions. So I want us to know only remaining with 2 topics. Actually 3 topics, and then we are done with the syllabus. Then we start going through all the past papers and make the marking here for the exam. So Z is less than negative 2.75. So already we know negative is on the left side. So we're saying less than, we're shading to the left. This shading is small. All right, so meaning the answer we're going to get, we're going to subtract from what? From our 1. So of course, these ones, they already direct from the negative table, but I want you to just use one table so that you understand the principle. So 2.75, when you read it, you subtract it from 1. So 2.75 go to 2.7 under 5. 2.75, 2.7 under 5. Okay. 5 is here, 0.75. So here we have 9970. You subtract 1 minus 9970. That's where you get the figure that they got here. All right. So greater than 1.62. Who wants to lead us through? Greater than 1.62. Z is greater than 1.62. Who wants to lead us? Yes. Cecilia, what do we do?
You mean sketching the,
Just take us to the
we
steps.
call it,
So let's use the ISA procedure.
okay, so the first thing we need to identify the sign,
Mm-hmm.
okay? And as we can see, the sign says greater. Am I right? It's
Yeah.
greater, right?
Mm-hmm.
Yeah, it says greater. So in this case, we'll know that when we come to the sketch,
Mm-hmm.
our shading
You start from here.
is going to, I
Uh,
start from here.
Illustrate
It's
first.
positive.
Illustrate, okay? Our 0 is here. The figure that we have
Yes.
1.62. So 1.62 using a number line. Is it on the left side of 0 or on the right side of 0? It's a positive number, so we can't put it this side. So put it here. 1.2.
It's on the right.
Then we put our divider. So now we need to step 2, shade. What determines the shading? The sign.
Yes, sir.
It is here, greater. Greater means shade to the right. Okay. Step 3, standardize. We don't need standardize. This is already standardized in terms of grade. Then we apply. What is application? Application is this is small. And when it's small, we read it subtract from 1. That's how we apply it. So when we go to 1.6. What is the what is the reading for 1.62? So we go to our table. 1.6, 0.02, 1.6, 0.02. But we get 94.84. So 94.84. So we subtract.
Isn't it 94.74?
94.
70.
1.6 what? 62, yes, 1.62, 94.74, thanks. So 94.74. Yes. So we subtract 1 minus 94.74. 1 minus 94.74. We get 0.0526. It's 0.0526. So when we do that, let's compare with what was done in the textbook. 1.62 greater, they shaded to the right. Then want to check this from the table. Remove 1.6, then across 0.02. The reading was 94.74. Then this is the area on the left from here to here. So what we want is the area on the right. So what do? We subtract from 1. So 1 minus 0.9474 to get 0.0526. So this is how we found the reading. Are we following?
Yes.
All right. So the other one was asking for intervals. All right. Between 0.47, 0.1 on the same side. So since on the same side, we just find the probability of the bigger number minus probability of the smaller number, subtract them. So probability of 0.186 is 96.86, 0.04 7 is 6808. Just subtract them. They're on one side. Even if they're on the other side, you subtract them. Question, suppose one was negative, one was positive. What do we do? We add
But on the same side.
on the opposite
Mhm.
side. Suppose they're on the one on the left, one on the right. We add the two probabilities and subtract one.
Okay.
Yes. Remember that case. So lastly, the next, there are certain times when you are not given the Z values themselves. So we use a standardization formula, which is given by Z is equal to mean minus mu over standard deviation. You standardize. So in this case, we're given, for instance, the mean is 10, the standard deviation is 3. Then part A, you're being asked to find the probability X is greater than 16. So you go to illustrate. Our mean we know is 0. But in this case, we haven't been given 0, we've been given a 10. Mean is 10. So we're told greater than 16. So based on the 10, our 16 is here. We put our divider. So using our principle ISA, illustrate, we have done shade, that's what we want to do. Where are we shading? It's saying greater, so we're going to shade to the right. It's the same principle, but just one small difference. Standardize now. So we learned the formula for standardizing is what? Z is equal to what? X minus mean per standard deviation. So our X is 16. Our mean is 10 divided by 3. So 16 minus 10 is 6. 6 over 3 is 2. So we know that the mean always standardized is 0. But this 16 we don't know. We've just calculated it. So the Z for 16 is 2. So when we read the Z, we're going to find that the reading for 2 is 0. What? 9772. Now this shading is small. So because it's small, we're going to subtract our answer from 1. So 0.9772. 0.9772 subtract from 1. Why are we subtracting from 1? Subtracting from 1 because it's a small shading. So our answer will be 0.0228. All right. Suppose the same parameters, mean is 10, now deviation is 3. And they're asking us to find the probability of X less than 13. Again, we illustrate using ISA. We illustrate. So here, our 10 is equivalent to the 0. Where's the 13? We can't put 13 on the left side of 10. 13 is here. Where are we shading? To the left side. So we have illustrated, we have shaded. Now we want to standardize. The biggest number in the Z table is 3. So you'll not find any 13. So we need to convert this to a Z, like we convert a quarter to a dollar. So we want to know what is this in terms of Z. The standardization formula is X minus mean over standard deviation. So 13 minus what? 10 divided by 3. So this will be 3 over 3, which is 1. So our Z is 1. So what is the shading? It is a big shading. So what are we going to do when we read? This is as good as what? Z less than 1. So we read directly. And we know that 1, we've now memorized 1 is 0.413. So this is about 84%. 84%. Now suppose we are told to find probability of X less than 6. Okay, now there's a small problem. 6 on the left side of 10. So we know that all numbers on the left side of the mean are negative. So we know this is 0. Where are we going to shade? this is less, so we're shading on the smaller side. But this 6, we need to standardize it. How do you standardize it? 6 minus 10 over 3. So we're going to have negative 4 over 3, which is negative 1.33. So already this shading is small. This shading is small. So whatever we're going to do, we will subtract from 1. So you round off to the nearest 2 decimal places if you're reading from the table. So let's go and read 1.33 from the table and what it corresponds to. So we'll go to a statistical table. By now we know how to read 1.3, that's 0.03. 1.33, it's 9082. So the reading from here to here is 9082. So how do we find the shaded region here? We subtract from 1. 9082. So when we subtract 1 minus 9082, we're going to get 0.0918. So this is the reading that we have here. It also follows that if we're going to say Z is greater than 7, Z is greater than 7. Also 7 is less than the mean that we have of 10. So our 10 is still here, our 7 is here. Where are we shading to the right side? It's not always that you're given the mean of 10. I'm just giving you that illustration because 10 has been given. In fact, the examiner will just come and do this. It's usually given mean, comma, variance. So they'll maybe just say n, then they put you 10, comma, 9. So it means that the mean here is what? 10. The variance here is what? 9. And the standard deviation is what? The square root of the variance, which is 3. That's how they just come in the shortcut here. So find x is greater than 7. So we standardize. So using ISA, illustrate, we've done. Shade, we've done. I want to standardize 7. So 7 minus 10, z is equal to mean, not mean, x minus mean over standard deviation. So 7 minus 10, negative 3 over 3, negative 1. So this is 0, this is negative 1. So we memorize our negative 1, or our 1 in short. The reading is, who remembers the reading for 1? 0.8413. Are we subtracting from 1 or reading directly as it is? We're reading direct. Why? Because the shading is indeed greater. Similarly, sometimes we may also be given intervals to do. We're told to find the values of Z between 13 and 16. So our narration has come in as 10, 9. So we know that our mean is 10 and our standard deviation is 3. Because when this is mean, this is the variance. Square root of variance is standard deviation. So we put our 10 there and our standard deviation is 3. So between 13 and 16. So 13 is here, 16 is there. So we know this is 0. 13 minus 10 is 3. 3 over 3 is 1. 16 minus 10 is 6. 6 over 3 is 2. So we're looking at this interval between 1 and 2. What is the reading for 1? 0.8413. What is the reading for 2? 0.9772. So the difference within the two is what we call our value. So it's a combination of everything we're doing. So here we're going to get 0.1359. All right. So let's go to our textbook and now the questions that come. So basically, I have labored hard to explain the principles when I given values in terms of Z, in terms of what? X. So when the question comes, For instance, in this case, suppose our mean is 15 and our variance is 100. So summarizing that, it means our mean is what, 15, and our standard deviation is 10. But find the probability that x is less than 20. So you go here. Step 1, illustrate. Okay. Would you want to try this or give you as homework?
Maybe we can take as homework.
Okay, I'll be happy you try this at homework. Okay, I'll send you this question. So we end here. Have a great day.
Thank you.
Thank you.
Don't forget to share the recording.